Hello, my name is Bayan, and I am a first-year master student from Electrical and Computer Engineering. Today my topic is designing nanostructures by glancing angle deposition. There is my outline. Today, firstly, in the introduction part, I'm going to explain what is glancing angle deposition and where it can be utilized. Then, shortly, we'll describe how researchers use nanostructures in their research. After that, I will explain the importance of this technique, and I will consider main problems and the possible solutions. In conclusion, I'm going to talk about future work. So, first of all, what is glancing angle deposition? It is a technique to obtain nanostructures on thin films. Its definition is deposition under an angle during rotation. In surface engineering, this application is developing. For instance, by this technique, different structures on thin film can be grown. There are three structures as constant, discrete, and continuous. In the right side of the presentation, there is a figure which shows schematic diagram of the glancing angle deposition. The deposition angle alpha is defined as the angle subtended between the substrate normal and the incident vapor. Azimuthal rotation about the substrate normal is measured by the angle phi. In general, a line connecting the centers of the substrate and the vapor source goes through the maximum of vapor flux plume. And by growing the structure on the substrate, it can be utilized on sensor and optical devices, solar cells, and energy devices. For instance, different research was done by researchers by using glancing angle deposition to grow thin layer of nanoparticles on nanowires, which can be used in solar cells. One of the examples can be titanium dioxide. For example, titanium dioxide nanowires and the nanoparticles were grown by using this technique, and the authors claimed that titanium dioxide nanowires more efficient than nanoparticle films. The efficiency improvement depends from geometry and porosity. In addition, for example, in classical areas such as optics or wear protection, where high compactness and low porosity are important, and the development of thin film deposition, procedures aimed at enhancing these morphological structures. So, thin film deposited by angle deposition have the following characteristics. The films are in general porous. The nanocolumns are tilting away from the surface normal to the incident evaporation beam direction. The size and the density of the nanocolumns change as function of the incident angle. It is one of the reasons why it is important. Another reason why this glancing angle deposition is important that it can improve performance of organic solar cells. It's a new opportunity for flexible optoelectronic devices. In many cases, there is a need to develop fabrication methods that can be capable to provide flexibility in the range of nanostructures. Nanofabrication techniques that can satisfy requirements of superior design freedom to scientists and engineers seeking to create and design freedom to scientists or devices based on unstructured materials. It is a good opportunity. Glancing angle deposition provides such freedom as it directly and accurately controls material structure across a range of size scales and allows creation of diverse array of columnar morphologies through modifications of the same basic technique. Moreover, various morphologies of nanostructured columnar films is shown in Figure 2. First is zigzag structure, which is a film where the column orientation switches back and forth. Helical structures are created by high alpha deposition coupled with slow substrate rotation, a motion that continuously redirects the column growth orientation and shapes the columns into helical structures. Third, vertical columns can be obtained by depositing at high alpha and with fast substrate rotation. The last structure is graded density, which can be grown by periodically modulating alpha between high and low values. Layers with these morphologies can be used as transparent conducting layers. So, the next I'm going to talk about main problems and the solutions. It is difficult to obtain zigzag structure form. Zigzag is depositing from alternating directions at high alpha realize a film where the column orientation switches back and forth. I tried to use equipment at Nazarbayev University from core facilities, which is called magnetron sputtering. And I looked images from scanning electron microscopy, which helped me to analyze the structure. The structure looks like graded density. In Figure 3, there is an image from scanning electron microscopy with first A with angle 45 degree and B 20 degree. So, in order to obtain the exact structure, the solution can be altering and considering main factors as deposition geometry, that is, the placement of substrate should be precise and repeatable to avoid run-to-run, for example, geometry variations. Next, we should consider chamber pressure and the gas composition. It is important to control the gas composition and the pressure because it reduces background gases, for example, dioxide. Then deposition rate. It impacts the nucleation and the condensation process during film growth. The substrate temperature. It is crucial to identify that radiative heating and vapor condensation will hit the substrate, which is important for low melting materials. Therefore, before starting the work or research or glancing angle deposition, it is important to search about these materials. The last factor is initial substrate condition. As glancing angle deposition is surface technique, is highly sensitive. Therefore, substrate rawness and the surface chemistry should be well controlled. So, in conclusion, today I talked about what is glancing angle deposition, where it can be utilized, and showed different research and how researchers use this technique in their works. Showed what the main problems and possible solutions for this problem. Then now I'm going to conclude my presentation by telling what will be done. First of all, I want to mention that glancing angle deposition layers have been used as transparent, conducting, and anti-reflective coatings in organic photovoltaic solar cells, or it can be used even in dye-synthesized solar cells. The aim for my future research is to obtain high electrical conductivity by using these nanostructured thin films, which will be obtained by glancing angle deposition, and to use it as a layer for solar cells. And in the future, I will try different morphologies, but the first aim is zigzag morphology. In order to obtain the zigzag form, I will consider the geometry and different angles, and assess the characteristics to estimate the efficiency. The equipment at Nazarbayev University will help me to evaporate, to grow the thin film layer. At Nazarbayev University, the equipment called magnetron sputtering will help me. Thank you for your attention.